In problem number 3, we're given the graph of a function, f, that's actually a piecewise function. We've got two lines and a quarter of a circle here. And I wrote right away that the radius is 3 of that circle. That's going to be useful when we're calculating the area under that curve. The other thing that I wrote right away here is that we're given the point 3 comma 3 minus root 5, and that tells us right away that f of 3 is equal to 3 minus root 5. We're going to need that in part B, where we're calculating the value of that integral. But in part A, we're given that the value of the integral from negative 6 to 5 is 7, but we're asked to find the value from negative 6 to negative 2. So I'm just going to write it up here. We know that the integral from negative 6 to negative 2 plus the integral from negative 2 to 5 would be equal to the integral from negative 6 to 5. So if I fill this in a little bit, f of x dx, here f of x dx, and here f of x dx, what's really important is these limits of integration here. Now, we are given that this is 7. So if we can just figure out from negative 2 to 5, then we can just subtract this integral from this, and then we'll get the value that we're interested in here. Okay, so from negative 2, if we start collecting the signed area underneath this curve, these two here will cancel out. These two will cancel out. And then the area here in this trapezoid would be 1 plus 1. So this is going to give us an area of 2. And then the area underneath this curve is a square minus a quarter circle. Now the square will be 9, and then a quarter of the circle will be 9 pi over 4 because of the 3 squared here. So we have the value of the integral as 2 plus this 9 minus 9 pi. Okay. Now if we know that this is 7, then all we have to do is subtract the 2 plus 9 minus 9 pi over 4 from the 7. Okay, all right, and you can finish that up on your own. Let's look at letter B. Letter B, we have the value of this integral, and this is just going to be 2f of x, because the antiderivative of f prime is f, plus 4x. So now all we have to do is evaluate from 3 to 5. So this would be 2f of 5 plus 4 times 5 minus 2f of 3 plus 4 times 3. And so if we can find these values, all right, we know that this is 20. We know that this is 12. And so now we just need to find f of 3. But here's where that one comes into play. And then f of 5, well, f of 5 is 0. So this part turns out to be 0. And then I'll let you figure that out from there. Okay? All right, now I'm going to jump all the way down to letter D, because when we did this in class, I suggested that we use L'Hopital's rule. But we don't need L'Hopital's rule here because it's not one of those indeterminate forms that we talked about last week. If I plug in 1 into the function, for each one of these, I'm going to get 10 to the first minus 3. Now, f prime would be the slope at 1, and the slope is 2, so that's going to be a 2. And then in the denominator, f of 1, okay, f of 1 is 1, and arctangent of 1, arctan of 1, going back to the unit circle, we would have 1 minus, okay, so if the tangent is 1, then we know that the y and the x values are the same, and so that must mean we have pi over 4. And in the numerator, we end up with 10 minus 6. Okay? All right, so you could write this as 4 over 1 minus pi over 4. Now, for part C, we're trying to find the absolute maximum. Okay? Now, to find an absolute maximum, we need to find where there is a possibility of g prime of x where it's equal to 0. All right, this could be a candidate, okay, where g prime is 0, where we have a local maximum, or we could check at an endpoint. Okay, so what we're interested in is from -2 to 5. So what we need is, what is g of -2? What is g of 5? And then any place where g prime is 0, where we have a local maximum. And earlier in our course, we know that f is going from positive values to negative values here, positive to negative. And f is actually a graph of g prime. So when is g prime equal to 0? Well, there's actually 3 places, here, here, and over here at 5. Well, 5 is already taken care of because we're going to find the value here. And -2, we know that that is 0 because the integral from -2 to -2 would be 0. So the only other places we have to check are g of 5 and at this local max, because it's going from positive to negative. So if we can find out what is g of -1, then we just have to compare these 3 and figure out which one is the maximum.